Hi, all. So today we're going to go over our 1.2 integers. And so our learning objectives for today are the following. We're going to be able to simplify expressions with absolute value, understanding what is absolute value, or our formal definition of it. We're going to be able to work with integers, be able to simplify expressions with integers. And then our last objective is going to be able to evaluate variable expressions with integers. So let's jump into it. Our second slide is going to just formalize our definition of absolute value. But in short, anytime you're thinking absolute value, you want to think of distance away from zero. And what do we know about this distance? Distance is always positive. So formally, we have absolute value of a number is its distance away from zero on the number line. The absolute value of a number n, we're just choosing n as our variable in this case, is written as, and then this is our notation mathematically. We have absolute value of n, where the absolute value of n is greater than or equal to zero for all of our numbers. And so more specifically, if we're looking at all of our values that are greater than or equal to zero, we have the absolute value of n is n. And if we're looking at all of our values that are less than zero, so think about all of our negative numbers, we once again, our absolute value spits out n. And from a more visual perspective, what does this mean? Well, again, distance away from zero, it does not matter whether we're looking at a negative value or a positive value. It's always going to end up shooting out to be positive in the long run. Let's say we were looking at the absolute value of -2 versus the absolute value of +2. Both of them will yield 2 units away from zero, which is how we defined it above. Okay, so let's jump into our example 1, where we have problem A, B, C, and D. Problem A, we want to figure out, okay, using our inequality symbols, our less than, greater than, or our equal to, what is our comparison? Well, we know that the absolute value of -5 is just +5. And the absolute value of -5, once again, is +5, but there's a negative number in front of that whole absolute value. And so the comparison between 5 and -5, well, we know that 5 is greater than -5. So there we have it. Let's go ahead and look at part B. We have 8 on this left-hand side. And the right-hand side, we have the absolute value of -8 is +8. But then we once again have a negative in front of that absolute value. The comparison between 8 and -8 is that 8 is greater than -8. Let's go ahead and move to C. -9 is on that left-hand side. Absolute value of -9 is +9, and then there's a little negative in front. The comparison between -9 and -9 is the fact that they're just both equal to one another. I can fill them in above here as well. And then finally, we're on part D. That left-hand side, we have -16 in parentheses multiplied by a negative. Negative times a negative gives you a +16. And then on that right-hand side, the absolute value of -16 is also +16. So the relationship is the fact that they are indeed equal to one another. And we're done. Let's move along. So we have another notes page, just talking about different grouping symbols. And so we have parentheses, we have brackets, we have braces, which we've talked about in our previous lesson together. But the additional one that I want to add to it is our absolute value. Absolute value sort of has two meanings. It's a way to group expressions together or group symbols or monomials together, um, as well as it also identifies two different scenarios, a positive case and a negative case. Whereas brackets and braces are most solely used for grouping. You'll see bracing is another way to represent sets in mathematics. And then parentheses is also used for grouping, but you'll also notice that parentheses is used for multiplication as well. All right, so let's move on now to example 2. We're not dealing with any variables quite yet. We're still dealing with just numerical values so that you guys can get a really good understanding of this. And anytime we have multiple steps when we're making computations, we want to use our order of operations, aka our PEMDAS. So parentheses, aka groupings, that's what we're going to take care of first. And so we have this 6 minus 2, which can be simplified to just 4. And then we're going to rewrite the rest of the problems. We're going to continue with the groupings. Let's take care of everything inside here. 3 times 4 gives you your 12. So now we're looking at 24 minus absolute value of 19 minus 12. And we have 19 minus 12 gives us 7. The absolute value of 7 is just positive 7. And so 24 minus 7 just gives us 17 as our final result. And we're done. So really breaking it up step by step until you guys get the hang of it is crucial, especially if you don't want to make any mistakes. Right? Another notes page when we're dealing with integers, more specifically when we're adding and subtracting integers from one another, what's going to happen to the sign, and how do we sort of tackle them. So anytime you're adding two positive integers to one another, it's going to stay positive. Anytime you're adding two negative signs to one another, it's going to stay negative. Remember, we're adding and subtracting here. We're not multiplying or dividing. Multiplying and dividing, different rules. Anytime you're adding a positive integer to a negative integer, it's important to know which of the values is larger, taking away that operation symbol. So let's say we had like positive 10 plus negative 28. We're going to neglect the operations right now for the time being, and we're going to ask ourselves 10 versus 28. Which one is larger? The 28 is larger. And now we're going to bring back our operation. So it's a positive 10 plus a negative 28. Well, the negative value is larger in this case. And so that's going to tell us that our final result is going to be negative. They used a different example here. In this example, the positive 6 was larger, so we know that our final result is going to be a positive result. And then we have a negative plus a positive. It's the same exact concept. It's just we're involving now our commutative property where we're switching the numbers around. You just want to use the sign of the integer with the bigger absolute value. This is a better way to define it. Take the absolute value and which one is larger. Okay, so now knowing that, why don't we tackle example 3 together? Again, really utilizing our PEMDAS. We want to take care of those parentheses first. So we have negative 4 minus 3. So they're both negatives. And so we know our final result is also going to be a negative. If I owe someone $4, right, it's -4, so I owe them 4. And then I owe them another $3. How much am I going to owe them in total? I'm going to owe them 7. And I'm going to rewrite the rest of the problem and continue. So this minus is really a -1 that we're distributing to that -7. So we're really looking at a +7 here. And so we have 7 plus 7 minus 9. 7 plus 7 is 14. And 14 minus 9 gives us 5. And we're done. That is our result. Now this is our note slides when we're dealing with multiplying and dividing integers. So when you multiply two negatives together, what happens? It turns to a positive result. And then when you multiply two positives together, what happens? It once again stays positive. But then when you have opposite symbols, that's when the negative dominates. So a negative times a positive is a negative, and a positive times a negative is also a negative. Division, same exact rule, but now instead of multiplying, you are dividing. So positive divided by positive is a positive. A negative divided by a negative is a positive. But anytime you have opposite symbols, sorry, my cat is being a little distracting right now. When we have a positive divided by a negative, we have a negative. Or if we have a negative divided by a positive, we also have a negative. So the biggest thing to sort of pull from this page is if the signs are different, it will always be negative. Okay, let's look at example 4 now. We have 4 different problems, A, B, C, and D. And so A, we have -100 divided is the same as all over in terms of a fraction, -4. We know it's positive because it's a negative divided by a negative. And how many times does 4 go into 100? It goes in 25 times. So our final answer is positive 25. Let's move on to B, where we're asking to find the product of 7 and 6, both positive numbers. We end up with 42. Part C, the product of +4 and -8. Positive times a negative is a negative, and 4 times 8 is 32. So -32 is our result. And then part D, -27 divided by +3, we're going to end up with a negative value, and 3 goes into 27 9 times. So -9 is your result. And we're done. Another notes page. Again, being able to simplify expressions with integers, we're still utilizing the whole order of operations, our PEMDAS, and the acronym that we use to sort of memorize PEMDAS is our whole please excuse my dear Aunt Sally. Parentheses, exponents, multiplication, division, addition, and subtraction. Okay. So now let's look at example 5 together. We have a part A and a part B. -2 raised to the 4th power. That's another way of expanding this into -2 times -2 times -2 times -2. We have an even number of negatives, so we know our result is going to be positive. And 2 times 2 is 4, times 2 is 8, times 2 is 16. So our final result is positive 16, and we're done. Now, B, we have negative 2 raised to the fourth, and there's no parentheses here. So what do we do in this situation? This is a very common mistake that students usually make. We want to do the blue first, and then whatever that result is, we got to tack on a negative in front. We already found out from the previous example that 2 to the fourth is 16. So our final result here is just negative 16, and we're done. Let's do another example together. We have an A and a B once again. 8 times negative 9. That's just negative 72. Divided by negative 2 to the third power. This is just negative 2 times negative 2 times negative 2, which will yield a negative in the denominator. And 2 to the third is just 8. Negative divided by a negative is a positive, and 8 goes into 72 9 times. So our final result is 9. Part B, we have negative 30 divided by 2, which is really just negative 30 over 2. That gives us negative 15. Plus, and then we have a negative 3 times a negative 7 gives us a positive. 3 times 7 is 21. Add the two numbers together, and we end up with positive 6. And we're done. And I can highlight. You can see what we're doing. We have a little comment slide. So remember that to evaluate an expression means to substitute a number for the variable in the expression. So now we can use negative numbers as well as positive numbers. And this sort of leads into our last objective for this lesson, which is evaluating variable expressions with integers. So let's look at example 7. We want to evaluate this trinomial, and we're given when x is equal to 2, so wherever you see an x, we're going to replace it with 2. And then when y is equal to negative 1. So wherever we see a y, we're going to replace negative 1. I always like to do parentheses first, just so I don't miss any negative or positive when I square the values. So I'm going to have 4 in parentheses squared, 2 in parentheses, and another in parentheses, plus 3 in parentheses squared. And then I'm going to color code. So we have a yellow here, a yellow here, and we have a light pink, and a light pink. Now I'm going to fill them in accordingly. We have 2. We have 2, negative 1, and we have negative 1. And now let's utilize our order of operations, our PEMDAS, to simplify. So parentheses and then exponents. 2 squared is 4. 2 times 2 is 4. -1 in parentheses squared is +1. Let's keep going. 4 times 4 is 16. -4 times -1 is a +4. And 3 times 1 is 3. 16 plus 4 is a +20. And 20 plus 3 gives us our final results to be 23. And we're done. So this concludes the end of our section 1.2. And then next time we'll be jumping into section 1.3. I hope this was helpful. Let me know if you guys have any questions. Take care.